Guys, we're almost there. The electron transport chain. This relies on four enzymes, and they're obviously named crazily complexes 1, 2, 3, and 4. We're not going to get into the structure of those, so don't worry too much because electron transport chain is another complicated step. Um, each of these complexes has enzymes, proteins, some metal ions. There's a lot going on, but what you should recognize is there's four steps. I think that's pretty easy. So a respiration chain here, electrons are transferred from one molecule to another. So essentially what you are is a biochemical battery. That's like the matrix all over again. Each time we transfer an electron, we get energy out of it. So that's great because we need that. Uh, and here's where we get this like electron transport. H plus ions move across the inner mitochondrial membrane. So what we're doing is we're transferring H pluses and electrons because we need a balanced charge. Energy is released like in little blips, so it doesn't all dump into your system at once. We wouldn't be able to handle that. Here you go. The complexes are embedded in the membrane. That's the mitochondrial membrane. Step one, we begin with NADH and one FADH2. Coenzymes donate electrons. So you can see we're kind of like just walking through this. Electrons are passed to complexes, and then the coenzymes re-enter the citric acid cycle. So this NADH and FADH2, we just continuously reuse them. Now, in reusing, sometimes they break down. That's why you need those vitamins. So our overall reaction is this: four electrons, four H pluses, and an O2, and we get two waters. This is vital for energy production. If this gets interrupted, we are in deep doo-doo. If toxins and different metals and poisons and things like that can disrupt what's going on here, and we can't have that. All right, lastly, here we go. Oxidative phosphorylation. What you need to understand, and this is not going to be crazy, but these relationships you need. H plus ions in the mitochondria. We have to pump these H plus ions back and forth, and we need energy for that. Energy comes from the redox reactions. We're exchanging electrons, and what those H's can do is they can convert ADP into ATP. And ATP we use for energy. So what we have to understand is for oxidative phosphorylation, all right? Because we're using hydrogen ions to convert ADP to ATP, which is our energy molecule. One NADH, one of these guys, will make 2.5 ATP. One FADH2 will make 1.5 ATP, and one GTP will create 1 ATP. All right. So when we bust through this whole spiel, the complete catabolism of one acetyl CoA will make 10 ATP, and this is where that happens. We got our NADH here, we get 2.5. NADH here, 2.5. That's 5, right? 2.5 and 2.5 is 5. Our GTP is 1 ATP, so that's 6. FADH2, that's 1.5 ATP, so 6 plus 1.5 is 7.5. And then our NADH gives us 2.5 ATP. 7.5 plus 2.5 gives us 10. Every time we dump one acetyl CoA into this cycle, we're generating 10 ATP when everything is firing on all cylinders. This is how we generate energy. To leave you with this chapter is to think about like what exactly is energy. I mean, like we consume food, but what does this mean? And I think that's one of those neat questions you can think about. What exactly is energy? Like, why do we have this ability to combust fuel and move automobiles? Why can we go eat a cheeseburger and then we house that energy in a particular way for a really long time? These are all really neat questions that are kind of fun things to think about.